All right, so um, right now we're going to look at rational functions and inequality. So I'm going to start out by looking at example 9. Example 9 says, find the range of values of x satisfying x plus 1 over x plus 2 is greater than 3. All right, I'm going to approach this question two different ways. This is the first way. So I'm going to have x plus 1 over x plus 2 is greater than 3. I'm going to have x plus 1 over x plus 2 minus 3 is greater than 0. The next thing I can do is I can make the left-hand side into one fraction, finding the LCM, which is x plus 2. Now, x plus 2 into x plus 2 is 1. 1 times x plus 1 is x plus 1, minus 1 into x plus 2 is x plus 2. X, and you're going to multiply that by the numerator, which is 3. So it's 3 times x plus 2. And everything on the left is greater than 0 on the right. Simplifying the numerator, we're going to have x plus 1 minus 3x minus 6 over x plus 2 is greater than 0. We're going to have minus 2x minus 5 over x plus 2 is greater than 0. All right, so the next thing I'm going to do is I'm going to determine the critical values. And you remember that the critical values are the values of x that is going to make both the numerator and the denominator 0. So we're going after the critical values. We're going to put the numerator equal to 0. So minus 2x would be equal to 5. And x would be equal to minus 5 over 2. Or minus 2½ That's one critical value. Let's get the other critical value. The denominator is x plus 2. And we're going to put that equal to 0. And so x would be equal to minus 2. So our two critical values are x is equal to minus 2½ and x is equal to minus 2. Next, I'm going to use the sign table. So I have values of x less than minus 2½ I have values of x less than minus 2, but greater than minus 2½ And the third range is x is greater than minus 2. Next, we have minus 2x minus 5, which is the numerator. The denominator is x plus 2. And the function is minus 2x minus 5 over x plus 2. And what we are searching for are the values of x that is going to cause the function to be greater than 0. Now, let us say for values of x less than minus 2½ So, for example, if x is minus if x is minus 3, a value of x less than minus 2.5 is like, for example, if x is minus 3, if x is minus 3, minus 2x minus 5 is going to come out positive. Because if x is minus 3, minus 2x would be minus 2 times minus 3, which would make that positive 6 minus 5, which would make it positive 1. So if x is minus 3, minus 2x minus 5 is positive. If x is minus 3, x plus 2 would be negative. And a positive divided by a negative is a negative. Now, if x is between minus 2 and minus 2.5, so that would be x would be minus, let us say, 2.25. If x is between minus 2 and minus 2.5, for example, if x is minus 2.25, minus 2 times minus 2.25 minus 5, this is going to come out negative. Minus 2.25 plus 2 is going to also come out negative. And a negative divided by a negative is a positive. Now, if x is greater than minus 2, for example, if x is, let us say, minus 1, if x is minus 1, minus 2x minus 5 is going to come out to be negative. Because if x is minus 1, minus 2 times minus 1 is 2, and 2 minus 5 is minus 3, which makes minus 2x minus 5 being negative if x is minus 1. If x is minus 1, x plus 2 would come out to be positive, and a negative divided by a positive is a negative. Now, my solution would be the values of x, where my solution would be the values of x, where minus 2x minus 5 over x plus 2 is greater than 0, or where minus 2x minus 5 over x plus 2 is positive. And the values of x for which minus 2x minus 5 divided by x plus 2 is positive, the solution is x is less than minus 2 and at the same time is greater than minus 2.5. All right, so let's take a second approach to example 9. All right, we could take this approach. Example 9 is asking us for the range of values of x satisfying x plus 1 over x plus 2 is greater than 3. A second approach that we could take to this is that we could multiply both sides of the equation by x plus 2 squared. So whenever you square something, it is always positive. So this is the equivalent of saying that you're multiplying both sides of the inequality by a positive number. And if you multiply both sides of an inequality by a positive number, the inequality sign remains the same. So I'm going to multiply the left side and the right side by the square of the denominator on the left side, which is to multiply by x plus 2 squared. And I'm going to multiply the right side by the same thing, x plus 2 squared. So the x plus 2 on the left cancels one of the x plus 2. So on the left, I'm going to have x plus 1 multiplied by x plus 2 is greater than 3 into x plus 2 squared. Simplifying the left side, I'm going to have x squared plus 2x plus x, that's plus 3x, and 1 times 2 is 2, is greater than 3 into x squared plus 4x plus 4. Simplifying, so on the left I have x squared plus 3x plus 2 is greater than, distributive law on the right, 3x squared plus 12x plus 12. Let's make one side of the inequality 0. Let's carry everything to the left side. I have x squared minus 3x squared. I have plus 3x minus 12x. I have plus 2 minus 12 is greater than 0. Simplifying the left side, I'm going to get minus 2x squared minus 9x minus 10 is greater than 0. Now, I don't like to see so many negatives, so I'm going to multiply both sides by a minus 1. So I'm going to multiply the left side and the right side by minus 1. Now, if you multiply both sides of an inequality by a negative number, if you multiply both sides of an inequality by a negative number, you must change the inequality sign. So we're going to end up with 2x squared plus 9x plus 10 is less than 0. You multiply into my 0, you're still going to get 0. Let's simplify. All right, so now let's simplify. All right, so in order to, now this is now a quadratic inequality. In order to solve a quadratic inequality, I could use the sine table method, or I could use the graphical method. In both cases, I would need the critical values. Now, the critical values are the values of x for which 2x squared plus 9x plus 10 is equal to 0. Factorizing, we have what? 2x squared plus 4x plus 5x plus 10 is equal to 0. 2x, we have x plus 2. 5, we have x plus 2 is equal to 0. We have x plus 2 multiplied by 2x plus 5 is equal to 0. So x plus 2 is equal to 0, or 2x plus 5 is equal to 0. So x is equal to minus 2, or x is equal to minus 5 over 2 are our critical values. Now, if I draw a sketch of this graph, I'm going to end up, it's a positive x squared graph, so it end up something like this. Let's get a better looking parabola. This would be my x-axis. And the x-intercepts are minus 2.5, which is minus 5 over 2, and minus 2. Now, I want the values of x for which 2x squared. So this is the graph, a sketch of a graph of y is equal to 2x squared plus 9x plus 10. I want the values of x for which 2x squared plus 9x plus 10 is less than 0. It would be the values of x between here. So between x is equal to minus 2 and x is equal to minus 2.5, it is clear that y is equal to 2x squared plus 9x plus 10 is below the x-axis, which is the line y is equal to 0. So this is the region of the graph where y is less than 0. And the values of x for which y are 2x squared plus 9x plus 10 is less than 0. The values of x, which are our solutions, are x is less than minus 2 and at the same time is greater than minus 2.5. All right, so example 8, we're looking at rational functions and inequality. Example 8 says, find the range of values of x for which x over x plus 1 is greater than 0. Now, I'm going to use the sign table approach. To do that, I'm going to need the critical values of x. So if I put the numerator equal to 0, I'm going to get x is equal to 0. And the denominator, let me just write critical values. So I'm finding the critical values. Now the critical values are the values of x for which the numerator and the denominator are equal to 0. So my first critical value is x is equal to 0. Let's put the denominator equal to 0. X plus 1 is equal to 0. Therefore, x is equal to minus 1. So my critical values are x is equal to 0 and x is equal to minus 1. Let me draw up my sign table. So I'm starting with values of x. X less than minus 1. Values of x for which x is less than 0 but greater than minus 1. And looking at values of x which are greater than 0. The numerator is x. The denominator is x plus 1. And the function is x over x plus 1. Now, when x is less than minus 1, for example, if x is minus 2, the numerator, which is x, would be negative. And the denominator, which is x plus 1, would also be negative. A negative divided by a negative is a positive. When x is between 0 and minus 1, for example, if x is minus a half, the numerator would be negative. The denominator would be positive, and a negative divided by a positive is a negative. Now, if x is greater than 0, for example, if x is 1, the numerator would be positive, the denominator would be positive, and a positive divided by a positive is a positive. So what I want are the values of x for which x over x plus 1 is greater than 0. Those are the values of x for which x plus x divided by x plus 1 are is positive, and the values of x, which are my solutions, and my solution is all x such that x is what? Less than minus 1, union all x such that x is greater than 0. So that is the range of values of x for which x over x plus 1 is greater than 0.